Hello, my name is Susank Pokhrel. Here I am going to show the vertical search engine and the document classification system. At first, let's start with the vertical search engine. This application is built to search the author profiles and their publications belonging to the department Research Center for Computational Science and Mathematical Modeling from the Pure Portal page of the Coventry University. This system allows the user to define the maximum number of the author to crawl. For demonstration, I'll set the max author to crawl to 5. Now let's start the crawling process by clicking on the Start Crawling button. But before accessing any page, the crawler first checks the website's robots.txt file to ensure that the requested pages are allowed to crawl. If crawling is permitted, then only it starts crawling the web page. Let's start crawling. Okay, here as you can see, it has started to crawling. It has also fetched the robots.txt file and it has found the crawl delay of the 5 seconds in the robots.txt file. If it has not found the crawl delay of the 5 seconds, then it will use the default 3 seconds scroll delay defined in the code. So while visiting the department Research Center for Computational Science and Mathematical Modeling, it has found total 47 authors profiles to crawl. Among the 47 authors, it will crawl only the 5 authors. So here we can see it has been crawling in the depth one. It has been crawling the authors, and now it is extracting the research paper or the publications from its author. Here we can see that from Rajgunnar Dena, it has extracted the 6 publications, while there is no any publications found for the Muhammad Hassan and Buchering. Similarly, it will go crawling all the authors, all the 5 authors, and extracts any publications from them. So here now it has also completed extracting all the publications, and now it is crawling the publications itself. Here we can see it has been started to crawl the publication itself. So let me pause the video while it crawls the publication, because it might take a certain long time to crawl all these 31 publications and 6 publications from Rajgunnar Dena. So once the publications crawling is completed, I'll resume the video again. Here now, since crawling has been completed, here you can see max pages crawled is 5 and index total publications is 37. Index built successfully. Correct. So here what is happening is in depth 0, the crawler collects all the list of the authors profiles. From that, it crawls only the top 5 authors, and from those 5 authors it extracts the publications, and in depth 3 it crawls all the publications. So now let's go to the statistics page. So this shows that how many publications were crawled and how many publications belongs to which year. So as you can see, there is only one publications that belongs to the 2017 year, and likewise similar wise. Also these values completely depends on the number of the authors selected to crawl. So now let's go to the search functionality. So from here we can search all the documents that has been crawled. So now let's search for like machine learning. Okay, so for machine learning it has found just one publications and its relevancy score is 12.28, where this publications was published on 2023 and the author of this publication was Raj Gunardana. I think this is because. So now let's search something like EEG. So okay, for EEG we can say two records. Both are from the authors Raj Gunardana and was published on year 2023. Relevancy score is this. Similarly, here we can search it by either by the year wise or the author. So let's search by year wise. So let's search the record of 2017. Since we already know that in 2017 there is only one publication, so it should only show one result. So here we can see that in 2017 the published article was Review of Bearing Witness and the author was Ellison Halford and its relevancy score is 10.46. So and below here in the let's go to the EG section here. Now in below here we can see the publication details. On here on clicking on the publication link we can directly visit the publication page directly. So now let's again go to the vertical search engine. So now here our vertical search engine also supports the scheduling. So by default it schedules on average 7 days, but for testing purpose I click on the bottom here, so that by clicking on this bottom it will start crawling immediately by calling the schedule functionality. So now let's move to the document classification. For document classification, let's go to the Google Colab. Here here for the document classification, I have collected the data set from the RSS feed from various news sources like the BBC, The Guardian, CNN, in different categories: business, entertainment and the health. Although the total target is set to the 1500, only the 400 articles were fetched. This maybe happens because of the limited availability in the RSS feeds. So here we can see the top 5 record of the extracted dataset. So here we can see only 163 articles were fetched in the category health, 123 articles were fetched for the category entertainment, and 114 articles were fetched for the business category. Now the TF-IDF vectorizer is converting our words to the numerical features. Our knife-based classifier is used to train these features. Here we can see our accuracy is 83%. So here we have also generated the confusion matrix to show the miscalculations where it may occur. So here we have some test inputs data. So test inputs data, it is showing that for stock markets drop, it has predicted the category as business, and for each category it is showing the confidence score. Similarly, here we have provided the interactive query prediction system. Here the user can give inputs and accordingly it will fetch the predicted category by using the knife based system. Also here the cosine similarity has been also used to predict the category. So here one example has been already entered. Thousands of children is facing fever. So NIBASE has predicted it to the health category, and while it has also shown the confidence score for health category is 0.687. So this concludes the demonstration of the search engine and the document classification. Thank you.